Well, a warm welcome to anyone joining. Thank you for being here. Go ahead and get yourself ready with a notebook, a pencil, or a pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today we have some problems from continuity for my AP Calculus students and Calc 1 students who might be studying for their Unit 1 exams covering continuity, the IVT, some limits, things like that. These problems I want to show you are what you can maybe expect to see in your upcoming test, as well as possibly on the AP exam. It's not common to see the IVT tested thoroughly. Continuity is a little bit more relevant. You'll see that a little more often, and you'll see different types of questions. So I wanted to give you a little bit of a spread on how continuity can be asked about, which of course is going to require you to know some things. It's going to require you to know the criteria for continuity at a point. And that's going to kind of dictate our processes here. Normally we're going to be looking at piecewise functions if we want to discuss continuity in like a really valuable way. Most functions you work with will be continuous, such as polynomial functions, exponential functions. Even a square root function is continuous on its domain. But there are some functions which are not continuous. They either have breaks or holes or jumps. So here are the questions. Give them a look. I'll give you a little bit of a closer look if you'd like. You can pause the video and take a gander, write them down in your notebook. Here's a multiple choice question. This is not a 4-part question. This is a multiple choice question. These are all relating to continuity. So give yourself about 12 minutes, maybe like 4 minutes each on average to solve these for yourself first. And then when you're ready, come on back. See how we did it here. All right, let's get started. The first thing we're going to do here is we're going to make some space. So let's get this moved over a bit. And then let's even get this one moved over a bit. Great. We're going to start off with interpreting the question, because calculus questions, especially about continuity, may not seem that informative or that, direct in what they want. It says determine the value of k that makes the function continuous. What does that really mean? Right? We want the function to be continuous everywhere. So we're going to focus on this potential breaking point. Where is it potentially broken? With piecewise functions, you should always be alerted of the domain of these piecewise functions, so that we have a potential, as Jordan Peterson might say, a potential breaking point at x equals 10. Because of course this is the majority of the function everywhere except where x equals 10. So x does not equal 10 for this piece. So how do we make this continuous? Well, remember that the criteria for continuity are that the limit exists. So we need the limit as x goes to 10 to exist. And not only do we need it to exist, we need it to be equal to f of 10. Well, f of 10 is k, according to this definition. The value of the function is k when x equals 10. So we have to be able to determine this limit and then just set it equals to k. So it comes down to being able to solve a limit, and there are many different types of limits. This one in particular is a limit involving a square root. So this is going to be the limit as x goes to 10 of the square root 2x plus 5 minus the square root of x plus 15 all over x minus 10. Now, of course, you can try to plug in 10, and if you do that, you're going to get square root of 25 minus the square root of 25 over 10 minus 10, 0 over 0, which is indeterminate, so we need to use this algebraic technique. What's the technique? Well, this kind of gives us a clue that we're going to be using conjugate multiplication. So we want the limit as x goes to 10 of square root of 2x plus 5 minus square root of x plus 15 And what we're going to multiply on the top and bottom of this fraction is the conjugate. What exactly is the conjugate? The conjugate is like the evil twin. It's essentially the same expression, but the difference, maybe I should duplicate this again since I'm multiplying this on the bottom as well. The difference is that our conjugate has a different sign in the middle, has the opposite sign in the middle. So that's not taking the insides of the square roots and making it 2x minus 5 and x minus 15. That is not the conjugate. The conjugate means that we have the opposite symbol in between the square roots. So the conjugate will be square root of 2x plus 5 plus square root of x plus 15. And I implore you, I insist, do not try to multiply this out in the denominator. This would be quite a nightmare, and it's not going to help you at all. The reason why we're multiplying by the conjugate, I'm not going to get too deep into how to solve these algebraic limits, you should know, but the motivation is that we basically have a difference of squares structure that we've created by having a minus b times a plus b. And so what that's going to work out to be is a squared minus b squared. The a value is a square root already, so the a squared is really just 2x plus 5 minus, don't forget to use parentheses here, x plus 15. Parentheses are your friend in calculus, whether you accept that or not, whether you want to accept them as your friends and buy them cookies on the weekends or not, they are your friends. They will save you from mistakes, because if you did not put parentheses, you would be doing plus 15 instead of minus 15, and that would just be wrong. You wouldn't get a convenient result here. Let's see what happens when we properly distribute the negative. We get 2x minus x, and we get 5 minus 15. Look at that, x minus 10 perfectly matches the factor we have in the denominator. So that is what we want. We want to be able to cancel this x minus 10 factor, because it's the issue with plugging 10 in. It was the problem. That's what was causing a 0 over 0. Now we do not have a 0 over 0 situation. Now we can totally plug in x equals 10 and not have any issues. So we can write the lim all the way up until the moment where we plug in the value. You must do that if you want full credit. I want to give you good habits, not bad habits. So this is 1 over 5 plus 5, or 1 over 10. And so that is exactly what our k value must equal. That means that the function is basically, this might not be the actual graph of the function, but the function is basically going up to a certain spot at x equals 10, but it has a hole there, and then it continues doing whatever. We need to fill that hole in order to make this continuous, and the way we do that is we set the k value right here where the hole exists. Right. Okay, let's take a look at the second problem here. Here's another kind of vaguely worded question. It simply says, discuss the continuity. Like, what does that even really mean, right? It's not even really a question. I had a student ask me, what does that tell me to do? It's not even a question. It just says, discuss the continuity. Well, that basically means determine whether it is continuous or not. So determine continuity or not. And if we have a discontinuity, it wants us to classify the discontinuity. So there are different types of discontinuities. Sometimes there's simply a hole, which we call removable. Sometimes there's a vertical asymptote, which would be an infinite discontinuity. Sometimes we have a jump discontinuity. So we need to be able to classify the discontinuity. And if you just think about it here, f of 7 is obviously not going to work. This is going to be undefined, because if you plug that in, you get 0 over 0. So we know it's not continuous. But next we have to, that's a bit about the discussion, a little bit about the discussion. It's not continuous at x equals 7. But we can say more. We can continue to discuss this by classifying the discontinuity as a jump or an infinite discontinuity or something. So a little bit of a reminder on how we deal with this function. This is technically a piecewise function. The square root of x, I do have a video on this, so you should check that out. The square root of x is just x. It doesn't change the number as long as the number is greater than 0. Technically, it could be equal to 0 and it won't change the number. Otherwise, we get negative x, and that's whenever x is less than 0. So therefore, if we take the absolute value of x and divide it by x, then this function just becomes positive 1 and negative 1. It becomes positive 1 when the x doesn't change, so when x is greater than 0. It becomes negative 1 when x does change, when x is less than 0. So how does that help us here? We have a very similar structure. We have absolute value of x minus 7 over, let's fix this a little bit, absolute value of x minus 7 over negative, parentheses are your friend, remember, just said that, x minus 7. So we pretty much have the 1, negative 1 situation, but since there's a negative in front, we're going to have a negative 1 and 1 situation. And instead of the turning point happening at 0, this is going to happen when x is greater than 7 and when x is less than 7. So now we can really discuss the continuity, or rather the discontinuity, precisely by investigating the two limits. From the left-hand side, this is just going to be negative 1. But from the right-hand side, this is not going to be equal to the limit on the right-hand side, which is going to be positive 1. So therefore, because the limit does not exist, because the limit as x goes to 7 does not exist, we call this a jump discontinuity. And if you graph that equation, you'll see exactly what I'm talking about. It basically literally just jumps in value at 7. It's a 1 for a while, then there's a hole, then it's a negative 1 for the rest. Okay, so that's about it. All right, great. Let's take a look at the third type of problem. So get used to these types. Get used to how they're describing this. Determine the value of k that makes it continuous is essentially asking you to just find the limit so that we can make this equal to that limit. They could have made it a little bit more complicated. They could have put like 2x minus k, and you would have had a little extra work to do. You would have had to like mess with the 20 and move some stuff around. But it's the same idea, that you need to make the limit equal to the point, and that will somehow find us a nice answer for k. Now, the second type, where we have discussion of continuity, you can't really imagine them asking you that on an AP exam, so they really won't, but they would ask that on a Unit 1 test, especially if you're in a college calculus class. They would phrase a question like this, or they would phrase a problem like this. It's not really a question. It's sort of more like a prompt. And third, we have, of course, another piecewise function. This is very AP-like. It's almost SAT-like in how they phrase the question. Determine the values at which the function is not continuous. And I should put like a parentheses here, because we don't technically know if it's one value or multiple values. Let's see our options. Well, our options are at these potential breaking points, which makes sense. These are all, again, to quote Jordan Peterson, these are all potential. If I do his voice, it'll maybe get copyrighted. So we need the potential breaking points. You see, any math student worth his salt knows how to find the breaking points. Okay, I'm done. I'm done impersonating the JP. So potential breaking point. I was thinking about my brother's car, I guess. These are potential breaking points, and how do we determine if they are broken or not? We need to determine if they're continuous by checking if the left limit is equal to the right limit. So if we want the left limit at 0, that is the equivalent of the limit as x goes to 0 for the piece which is to the left of 0. So that's going to be x squared. See that? And of course, this is just equals to 0. Now, on the other hand, the limit as x goes to 0 from the right is essentially just the limit as x goes to 0 of the piece on the right side of 0, so just barely greater than 0. See that it says 0 less than x, which means x is greater than 0. We're just going to use the square root of x, and if we plug in 0, we get 0. So this limit does exist. We're good to go. So we know the answer is not C, because 0 is a value at which the function is continuous. We want the value or values at which the function is not continuous. So we've considered x equals 0. We determined that it's continuous there. Now let's move on to x equals 1. And that's pretty easy to just like fix all of this. So when we're going to 1 from the left or 1 from the right, 1 from the left is going to be this piece here that we used, the square root of x. And of course, square root of 1, oops, wrong spot. And of course, the square root of 1 is just 1. Whereas on the right side, we're going to be using this piece on the right, 2 minus x. And 2 minus 1 is definitely 1. So again, we get continuity. So it is continuous at x equals 1. So it definitely cannot be these ones. So it has to be option B. Let's just confirm that it is not continuous at x equals 2 by checking the limit from the left and the right side of x equals 2. Noticing that the left side is going to be using the third piece, this piece here, 2 minus x, and 2 minus 2 is just 0. Meanwhile, on the right side of things, we will be using this bottom piece, x minus 3, and 2 minus 3 is negative 1. So we do not get continuity there. That is exactly what we predicted, that the function is not continuous only at x equals 2. All right, I think that's some good, clean continuity family fun there for you guys. I want to emphasize that you need to know the criteria for continuity, which is that the limit needs to exist, and it needs to be equal to the function value. Usually this means we're going to be finding a limit. That's generally what problems have you do because there's more work involved than just plugging in a value c. And a lot of times you'll need to use this equation to motivate your work, just like in problem number 1. Whereas in problem 2, they have us discuss the continuity. There's not like one way to do that problem. It depends on what kind of function you get. Generally, they'll be having you use limits in order to investigate this further, just like we did here. The limit from the left and the right were not the same, so we can classify the discontinuity. And the third problem, a little bit more of like a multiple choice test standardized problem that has you consider some options, some combinations of those options, only 1 or 0 and 2 or 1 and 2, and we still need to use the definition of continuity and more specifically the left and right sided limits to confirm that the function is continuous. And then we have to be careful because the question actually asks where it's not continuous, so be very careful about that. All right, I think that is enough blab out of me. I will see you guys next time. Good luck on your tests.